Hello everyone, thank you for watching this video. My name is Islam Mamadov and this is my project which is named Microscopic Traffic Simulation SUMO to model and assess intelligent parking management strategies. So let's start from the first slide. And by the way, this is my thesis project and I'm gonna show you my current progress and describe the next steps. So to bring my project to life, I used a few key tools and when we looked at how parking is managed in most cities today, we noticed some common problems. A big one is that most systems still use static route guidance and fixed pricing. That means they don't really adapt when traffic patterns or demand change, which often leads to frustration and wasted time. On top of that, many drivers don't actually follow the parking guidance they are given, usually because of the information is outdated or just doesn't feel reliable. And even though park and ride is a great idea in theory, it's often underused because it's not well connected to public transport or doesn't seem worth the hassle. I also saw that there are not many incentives for people to make greener choices, like using electric vehicles or parking in less crowded areas. And overall, there's no real system in place to balance the load across parking lots. Some get jam-packed while others sit nearly empty. And finally, parking and public transport rarely work together in real time. So even if someone wanted to use both, mismatched schedules can make the experience harder. And for this project, I use, as I mentioned before, SUMO, which lets me model traffic and parking behavior on a very detailed level. And I use Python scripts to handle things like injecting vehicles into the simulation, assigning roads, and managing parking behavior. For the road network, I pull real-world data from OpenStreetMap, so the simulation reflects an actual urban environment. And a chosen map is Budapest. And to tweak the simulation settings like vehicle properties or parking rules, I use XML. So with this system in place, we are expecting a few key improvements. First, by reducing the time people spend circling for parking, we should see a noticeable drop in carbon gas emissions, which is great for both traffic flow and the environment. And dynamic pricing is expected to boost park and ride usage by around 30%, helping shift traffic away from the crowded city centers. And I'm also aiming for better driver compliance by offering personalized real-time routing that actually adapts to what's happening on the road. And overall, the combination of smarter guidance and better use of existing infrastructure should lead to a solid reduction in congestion across the network. And current results. Here is what I've achieved so far in the simulation. First, I've generated a detailed road network by extracting real-world data from the OpenStreetMap that gave me a starting map file from Budapest. Then I converted that into a simulation-ready network using netconvert, which gave me the netxml file that Sumo needs. And then I created around 1000 random vehicle trips to simulate real traffic across the network. And parking areas were dynamically identified and extracted using a custom Python script, which allowed me to define where and how vehicles can park. And finally, I implemented vehicle stops using Sumo's parking area feature, so cars are actually parking for a set duration before continuing their journey or ending it. This setup gives us a realistic environment to test the impact of different parking strategies and guidance systems. While the simulation setup is working well, there are still a few limitations I'm working through. One is making a park and ride system and its behavior more dynamic right now. So I'm exploring ways to better reflect how drivers actually chose park and ride in real time. Another challenge is fine-tuning the route guidance cost functions. Ideally, routing decisions should factor in not just travel time, but also parking availability and maybe even driver preferences. That's something I'm still calibrating. And finally, I want to build out more traffic scenarios. Right now, I have a working model, but comparing baseline traffic to intelligent parking strategies under different demand levels will give me a much clearer picture of the real impact. Moving forward, my next steps are focused on wrapping up the evaluation and presenting the results clearly. First, I'll design a proper evaluation framework to measure things like travel time, parking efficiency, and emissions across different scenarios. Then, I'll run comparisons between the baseline, parking right strategies, and dynamic guidance to see which approach performs best under various conditions. I'll also start generating visual outputs, like I'll try to create some charts, graphs to help make the results more understandable and impactful. Alongside that, I'll write up a detailed analysis for each scenario to explain what's working and why. And finally, I'll compile everything into our thesis documentation to get it ready for submission. This is all for the slides, and now I'm gonna show you the simulation and how it works. Setting it to real world. This is the map from Budapest that I extracted from OpenStreetMap, and let's run the simulation. So here are the vehicles, they're starting moving. Okay, this speed is okay. No, yes, now. Yeah, so vehicles are moving across the map and parking and then continuing to the movement, as we can observe. Thank you for the watching.